You know that humming metal box in your neighborhood? The one you probably walk past every single day without a second thought? Well, it turns out that box makes your entire modern life possible. In this explainer, we're going to pull back the curtain and reveal the unsung hero of our electrical world, the transformer.
Seriously, you've definitely seen one of these. Maybe it's on a concrete pad in a park, or perched up on a utility pole, just kind of humming away to itself. But have you ever stopped and wondered, what is that thing actually doing?
Well, that box is a transformer. And let me tell you, without it, plugging in your phone, watching TV, or even just flicking on a light switch would be completely impossible. It is the final, absolutely critical link that brings electricity safely into your home. Now, to really get why this box is such a big deal, we need to understand the fundamental problem with electricity. It has to travel a very, very long way to get from where it's made to where we use it. Think about it like this. Imagine electricity is water flowing through a super long hose. The longer that hose is, the more friction there is, right? The flow gets weaker and weaker at the end. Well, for electricity, that friction is called resistance, and it basically turns all that precious electrical energy into useless, wasted heat. And the amount of waste is just staggering. If we tried to send power from the station at the same low voltage our homes use, we would lose 87% of the energy before it even got to us. Almost all of it would just burn up as heat in the wires, a total waste. So the solution is really, really clever. Instead of just trying to force the power through, engineers figured out how to change its form for the trip. They can't make more energy out of thin air, but what they can do is crank up its electrical pressure, what we call voltage, way, way up. So how do you change voltage? You might think it takes some super complicated machine, but it's all done with a simple, elegant principle that honestly feels a little bit like magic: magnetism. You see, at its heart, a transformer is beautifully simple. It's really just two separate coils of wire wrapped around the same piece of iron. That's it. One coil takes the power in, the other sends the power out. And here's the crazy part. They never, ever touch. So how does the energy make that jump with no connection? It's genius. The electricity flowing into that first coil creates an invisible, pulsing magnetic field. The iron core acts like a superhighway, guiding that entire magnetic field over to the second coil. That moving, pulsing field then literally pushes the electrons in the second coil, creating a brand new electrical current. It's kind of like one spinning wheel making another one spin just from the wind it creates. No physical contact needed at all. And this little trick is exactly why transformers only work with alternating current, or AC. See, with AC, the electricity is constantly flipping direction, surging back and forth. This creates that moving, pulsing magnetic field that we need. If you try to use direct current, or DC, which flows steady in one direction, kind of like water from a tap, the magnetic field would just sit there. It would be stagnant and unchanging. And a static field can't push the electrons in the other coil. You need that constant change to make the magic happen. Okay, so now that we get the how, let's follow a little packet of energy on its epic journey, all the way from a massive power station right to your phone charger. All right, the journey starts at the power plant. Here, a gigantic step-up transformer takes the electricity and boosts its voltage to a mind-boggling 400,000 volts. You can think of this as cranking the pressure way, way up so the energy can be pushed efficiently across the country through those big power lines with almost no loss. So once that super high voltage power gets to the edge of your town, it's still way too powerful and dangerous for local streets. It goes into a substation where a big step-down transformer does the exact opposite. It drops the voltage way down to a more manageable but still pretty hefty 11,000 volts. Now it's ready to be set along your neighborhood streets. And here we are, right back at that green box in your neighborhood. This is the final stop. This local transformer takes that 11,000 volts from the street and steps it down one last time to the safe, usable 240 volts that all of your home's wiring and appliances are designed to handle. So this whole process sounds pretty perfect, right? Well, not quite. You see, even this amazing device isn't 100% efficient. A little bit of energy always gets lost along the way. Nope, it's not. If you've ever stood near one of these transformers, you probably noticed two things. It feels warm, and it makes that constant, low humming sound. Well, that heat and that hum, that's the sound of wasted energy. The iron core heats up, and the magnetic forces cause the metal inside to vibrate thousands of times a second, which we hear as that classic hum. To really understand this inefficiency, there's a fantastic analogy. Imagine the power coming through the transformer is a glass of beer. The actual beer, the liquid gold you really want, that's the true power that actually runs your laptop and your lights. But, there's always that foam on top. That foam is reactive power. It's useless energy that the system has to handle, but it doesn't do any real work. It's just waste. The entire glass, beer and foam together, is the total apparent power that the transformer has to deal with. So you can think of the transformer as being the glass itself. Its size tells you how much total power it can handle, the beer plus the foam. Now, here's the cool part. The more efficient your appliances are, the more useful beer you get in that glass, and the less useless foam the whole system has to deal with. So when you take a step back and look at this whole journey, it becomes so clear just how essential this simple device is to our entire way of life. And they really are everywhere, working on every imaginable scale. You've got the colossal ones at power stations that serve whole cities, then the one in your neighborhood for your block, all the way down to that little black box on your laptop cord, and even the tiny, tiny one hidden inside your doorbell. They all do the exact same job, just for different needs. Their job is simple, but it is absolutely crucial. Change voltage up or down as needed. That's what lets us move power efficiently across huge distances and then deliver it safely into our homes in just the right shape for all our gadgets. So the next time you walk past that humming metal box, you'll know exactly what's going on inside. It's the silent, hardworking hero of the electrical grid. And really, every time you flip on a light switch, you can thank this humble but absolutely ingenious device, a perfect piece of incredible science hiding in plain sight.